Hi guys, welcome to Science Chomp. Today it's going to be part 1 of specific heat capacity. Specific heat capacity is the energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. And its formula is this thing over here, where Q is the energy, C is the specific heat capacity, M is the mass, and delta T is the change in temperature. Sometimes you might see the Greek symbol theta. It's the same thing. So Q equals MC theta or Q equals MC delta T. It's the same thing. Now, the way we use these triangles, if you want to work out C, you cover it up and you see what's left. So that's C equals Q divided by M times delta T. If you want to work out delta T, it's delta T is Q divided by M times C. If you want to work out the mass, cover it up. Mass equals Q divided by C times delta T. And of course, if you want to work out Q, you cover that up. And what you're left with is MC delta T. Now, this is slightly different to thermal capacity. Thermal capacity is the amount of energy required to raise the temperature of an object by 1 degree Celsius. So thermal capacity is M times C. But you very rarely get thermal capacity questions. Usually it's always specific heat capacity questions. So this is what I'm going to focus on here. So I've printed off a couple of questions. So we'll do the top one first, number 32. It says a block of metal absorbs 2,000 joules of thermal energy. The temperature of the block rises from 10 degrees Celsius to 20 degrees Celsius. The mass of the block is 2 kilograms. What is the specific heat capacity of the metal? So the very first thing that we do is we write down everything that we know. So Q is equal to 2,000 joules, as it mentions there. The temperature, so delta T goes from 10 to 20 degrees Celsius. So that's basically plus 10 degrees C. What else is there? The mass is 2 kg. Okay, so then all we do is we plug in the formula to find out C. So we want to work out what C is, the specific heat capacity. So we do C is equal to Q divided by M delta T. And again, this is from that equation. Let me show you that triangle one where you got Q is MC delta T, like that. So again, you cover up the C and you got M times delta T. So let's just put in the numbers. So it's 2,000 for Q, mass is 2, and that's 10. So that's the same as 2,000 divided by 20. And that gives us 100 joules per kg degrees Celsius. Let's try one more question. Our next question says, a block of copper has a mass of 2 kg. The block of copper absorbs 12,000 joules of thermal energy. The specific heat capacity of the copper is 385 joules per kilogram degrees Celsius. What is the temperature rise of the copper? Seems simple enough. As before, the first thing is that we write down everything that we know. So mass is 2 kg. Q is 12,000 joules. Specific heat capacity, C, is 385 joules per kilogram degrees Celsius. And we want to work out delta T. So delta T, if you cover it up, Q divided by MC. Q is 12,000 divided by 2 times 385. So let's do that very quickly. 12,000 divided by, in brackets, 2 times 385, close the bracket, equals 15.58 degrees Celsius. Simple as that. I've got a few more trickier type of questions in part 2, so stay tuned for that. Thank you very much.